Hello, geometry students. Here's your lesson for section 4.3, Angle Relationships in Triangles, with Missy McCarthy, math instructor at Oak Mills High School. There's lots of I can statements for this one. By the end of the lesson, you should be able to recite and apply the triangle sum theorem, identify exterior angles and their remote interior angles of a triangle, know and apply the exterior angle theorem. You should be able to know and apply the third angles theorem, use the corollaries of the triangle sum theorem, and you should be able to write geometric proofs using the triangle sum theorem, exterior angles theorem, and third angles theorem as justifications. So let's get to it. We've got lots to do in this one. All right, so the first theorem that we're going to tackle right away is the triangle sum theorem. And it's something that you guys are probably already familiar with. I've heard students in class talking about this already in today's lesson. But it is a theorem that simply says that the sum of the angles in a triangle is 180 degrees. So if we were to write this as an if-then, we would say if angles A, B, and angle C are the angles in a triangle, then the measure of angle A plus the measure of angle B plus the measure of angle C equal 180 degrees. Okay, so that is one of the most important theorems. You will use that theorem a lot when you're talking about the angles of a triangle. Okay, so that's the triangle sum theorem. Sometimes I will shorten it and just draw a triangle and write sum and theorem. Okay, so that's the triangle sum theorem. The angles in a triangle add up to 180 degrees. All right, so the proof of the triangle sum theorem is actually somewhat of a difficult proof, in that one of the things that you have to use for the theorem, for the proof of that theorem, is not readily, you wouldn't think to use it, and that's something called an auxiliary line. This line L right here is an auxiliary line, and we're going to say that this line L is parallel to segment AC. And that's going to help us prove the triangle sum theorem. Okay, so first we're going to start with knowing that that's given to us. Okay, so I'm going to put L is parallel to segment AC. That is given. So if L is parallel to AC, then that means if I use AB as a transversal, I have some alternate interior angles that are congruent. So I know that angle 1 is congruent to angle 4. That's by the alternate interior angles theorem. And then if I use BC as my transversal, I know that angle 5 is congruent to angle 3, also by the alternate interior angles theorem. Okay, so I've got 1 is congruent to 4, 3 is congruent to 5, 2 is congruent to itself by the reflexive property. Angle 2 is congruent to itself by the reflexive property. Okay, what else do we know? We know that angles 4, 2, and 5, all of those angles form a straight angle. So I can say, let's say, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180. And I'm going to say that's given to us in the diagram. They form a straight angle, and we know straight angles are 180 degrees. Or we could say, actually, we could say this. We should say this. They form angle 4 and angle 2 and angle 5 form a line that, or form a straight angle. That'll be more specific. Form a straight angle, and that's given. And so then we can say that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180, and that is by definition of straight angle. Definition of a straight angle. All right, so we're almost there. The only thing I want to do now, I'm trying to prove that 1 plus 2 plus 3 equals 180. So somehow I want to get 4 out of there and I want to get 5 out of there. So I'm going to go right back up to these statements, and I might not finish this proof off. I might just go right back up here. I want to get 4 out of there, and I want to get 5 out of there, and I want to replace 4 and 5 with 1 and 3. So the finishing touches of this proof would just to be to say that means the measure of angle 1 equals the measure of angle 4, and the measure of angle 3 equals the measure of angle 5, and that would be by definition of congruence. And then if I were to take 1 and 4 and 3 and 5 and do some substitutions in this step right here, then I would get the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, which is what we were trying to prove, and that would be using the substitution property of equality. And so there we have it. We've proven that all of the triangles, all of the angles in a triangle add up to 180 degrees. Okay, so quickly looking at this example, after an accident, the positions of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collected to find the indicated angle measures. So they just tried to give it some fancy context, but really they just want us to find measure of angle XYZ. XYZ, so we're looking for this angle right in there. Well, if all of the angles add up to 180, and we know this one here and we know this one here, we could do 180 minus 62 minus 40. These two together are minus 102. So 180 minus 102, that tells us that angle has to be 98 degrees. Oh, 78 degrees, my bad. Okay, all right, so now we're going to look for the measure of angle YWZ. YWZ, so that's this angle right here. That's the one we're looking for. We know this one here is 12, so we're looking at the skinny triangle. We know this angle right in here is 12 degrees. These two angles form a linear pair, so if this is 162, this one has to be 118. 118 plus 62 would add up to 180, and so now we're trying to find this guy right in here. So we would do 180 minus 118 minus 12 degrees. So 180 minus 118 would be 62, and then 62 minus 12 would be 50 degrees. Really hope I did that correctly. Okay, so next I'm just introducing you to this thing called a corollary. And the corollary is a theorem whose proof follows directly from another theorem. So oftentimes, if you were going to prove a corollary, you would start with the previous theorem and then you just add a couple steps to it, and that's how you prove a corollary. But for lack of a better term, a corollary is just another kind of a theorem. It just happens to be related to other theorems. So in this section, we're going to have two corollaries that are related, a direct consequence of the triangle sum theorem. So those two corollaries from the triangle sum theorem, remember the triangle sum theorem says that all the angles add up to 180. So a direct extension of the triangle sum theorem means that if you have a right triangle, the acute angles in a right triangle are complementary. If this is 90 and all of the angles add up to 180, then that means these two angles have to add up to 90. Okay, so it's the triangle sum theorem, but applied to a right triangle. So that's our first corollary. So if you have this picture, it's okay to assume that angle D and angle E are complementary. And then measure of angle D plus the measure of angle E equals 90 by definition of complementary. Likewise, the next corollary that's an extension of the triangle sum theorem says the measures of each angle of an equiangular triangle is 60 degrees. Well, if they all add up to 180 and they're all equal, That means 3 of them have to add up to 180. And then if you divide both sides by 3, each of them has to be 60 degrees. So in an equal angular triangle, it is okay to say that the angles are 60 degrees by this corollary from the triangle sum theorem. Now we have a different kind of angle in this triangle that we haven't talked about before. If you take any triangle and you extend one of its sides, you've created an angle on the outside here that I just colored in, and that angle is what we would call an exterior angle. Okay, so that would be the exterior angle. And then the other 2 angles that are on the inside, there and there, these are what we would call remote interior angles, because they are away from the exterior angle. 3 is not a remote interior angle. It's touching the exterior angle. But 1 and 4 are what we call, 1 and 2 are what we call remote interior angles, and 4 is what we call an exterior angle. So we have a theorem that goes along with this called the exterior angles theorem. And the exterior angles theorem says that if you have a triangle, the measure of the exterior angle is equal to the sum of the measures of the 2 remote interiors. In short, the measure of angle 4, which is the exterior angle, is equal to the sum of the measures of angles 1 and 2. And that's it. We're not going to do the plan for the proof because we're going to prove this one in class. So right now we're just going to use the exterior angles theorem. So that means that this guy right here, the measure of angle BCD, is equal to the measure of angle A plus the measure of angle B. So we get 5x minus 60 is equal to 15 plus 2x plus 3. So that gives us 5x minus 60 is equal to 18 plus 2x. Subtract 2x from both sides and you get 3x minus 60 is equal to 18. Add 60 to both sides and you get 3x is equal to 78. And then you divide both sides by 3 and you get x is equal to 26. So if we want to find the measure of angle B, we would plug that right back in here. And we would do 2 times 26 plus 3. That would be 52 plus 3. So the measure of angle B would be equal to 55 degrees. So that was using the exterior angles theorem. All right, our last theorem is called the third angles theorem. This section just has tons of theorems. And the third angles theorem just says if 2 angles in one triangle are congruent to 2 angles in the other triangle, then the third pair of angles also has to be congruent. So if L is congruent to R and M is congruent to S, then that means that N has to be congruent to T, and that's the third angles theorem. So in this example, we have 2 triangles. We have triangles FKH and we have triangle JGI. So what we know is that angle F is congruent to angle I. We also know that angle G is congruent to angle H, so therefore it is safe to assume that angle K is congruent to angle J. So if that's the case, we know that 4y squared is equal to 6y squared minus 40. Then we can subtract 6y squared on both sides. We get negative 2y squared equals negative 40. Divide both sides by negative 2. And we get y squared equals 20, and then take the square root of both sides, and we get y is approximately 4.47. You could do y is equal to the square root of 20, and do equals the square root of 4 times the square root of 5, which is the exact answer to square root of 5, and then this is an approximate answer, 4.47.